Hi guys, today is a special day. This is a project, the first project of our new course of hybrid and electric boats. And in this project, I am going to explain in a simple way the procedure to convert a typical boat with an internal combustion engine, diesel or gasoline, into a hybrid or full electric boat. This is the deal. I removed this motor with this transmission from a sailboat 38 feet, and the idea is that I am going to replace this diesel engine, 16 horsepower, with an electric motor. Of course, the electric motor is supposed that have a torque equal or superior to the torque produced for that diesel engine. Yes, I found the motor. I have a three-phase motor. This motor, that motor was originally in a pump. I am going to use the motor, and the motor will be fit with an inverter, and the inverter convert 48 volts DC into 3 phases AC, and those 3 phases enter here in the motor. That's too simple. The secret is the motor and the inverter. That inverter, in the terminology for a hybrid boat, the people say a converter. Yeah, convert DC into AC. All right, the inverter, this is a inverter produced for electric yachts, and I am going to connect with the NEMA connections, those type of NEMA connections. I am going to connect the control for the throttle, and also the ignition switch, and the main display. The main display will be integrated with the NEMA connectors, with the inverter, and the inverter will be integrated with the motor. After the motor, I am going to remove the impeller from the original pump, and I am going to install here the transmission, and after that I am going to install the shaft and the propeller. In the transmission, as soon as I separate the transmission from the engine, I am going to use the flex plate. The hub of the flex plate will be used to fabricate the coupling to adapt the electric motor with the transmission. This is the most important part. I'm going to explain that process step by step. We are going to use the same transmission. We are going to keep the transmission in the boat if the transmission in this particular case is not cooled by raw water. But if the transmission will be cooled with the raw water, we can install an electric raw water pump 12 volts. In this particular case, the boat will be 48, the battery bank will be 48 volts, but no problem, because we are going to use a DC to DC converter to convert 48 into 12 to provide power for the electric pump. That's simple. This is not an issue. We are going to solve that situation easily. All right, this is the propulsion system, and now I am going to explain what is the process that we are going to follow in the house with the DC panel, with the AC panel, and how we are going to integrate the house with the NEMA 2000, and how we are going to integrate other analog elements into the main display of the boat. This is the most interesting part. Okay, this is the second part. Okay guys, this is the second part of this conversion, this electrical conversion. All right, I mentioned before that my recommendation is start for the propulsion system. Okay, once you finish the propulsion system, the idea is convert the house. What is the idea with the house? This is a traditional boat with an AC panel and a DC panel. Okay, I want to keep those panels, the AC and the DC panels, both of them. But I want that those panels right now be integrated with the inverter charger Victron, and the products of Victron, and the product of those intelligent network. All right, this is the idea. I am going to continue with my traditional AC panel, 120 volts AC. I install additional gauge and meter, voltmeter, analogs and digital. That's the traditional panel. I am going to connect in the outlets a couple of air condition units. One air condition unit 120 volts AC, and other unit 48 volts DC, and we are going to check the performance, the efficiency of both of them. All right, this is in the output of the AC panel. The DC panel will be located here, probably in the next coming episode. I want to show you the DC panel integrated here. But the rest is simple. I'm going to create a battery bank like this. The battery bank is with cells of 3.3 volts each one, connected in series. At the end we have a 12.4, 12.3 volts DC, and each cell is 400 amps. Okay, at the end we have a 12 volts, 400 amps. This is a great battery bank. And also we have an intelligent generator. In this particular case, it's a portable generator, but will be located fixed in this for this project. In other project, we are going to use a diesel generator, marine generator, but for this project, it's okay. This is an intelligent generator, and that generator will be activated automatically from the Victron system. I am going to program the Victron system, the Servo GX. In the Servo GX, I am going to send the signal to start the generator when the level of charge of the battery bank decreases 25%. When the level of charge will be around 75%, immediately the Servo GX sends the signal in the position relay to start the generator. I'm going to explain later how is that process. Okay, this system received the 12 volts from the battery bank. The 12 volts passed through the shunt. The shunt is connected with the display, the small display over there on top. That's the display corresponding for this smart shunt. All right, and the shunt, I have two shunts, this one and the smart shunt of the system connected in series with the link distributor. The link distributor receives power from the solar panel systems, from the MPPT, and also will receive power from the windmill. I'm going to install a windmill. We have the windmill and the solar panels, and the output will be the power for the inverter and other output for the DC panel. In other words, in that intelligent link distributor, we are going to administrate the current DC coming in and the current DC coming out. And we have administration in the main display about how much current enter, how much power enter, and how much power is going out. That will be nice, DC. And also AC, because in AC we are going to connect shore power, and we are going to connect generator. Both of them administrated for the automatic transfer switch. The automatic transfer switch will detect if the power is coming from the shore power or if the power is coming from the generator, pass automatically, and always the power enter in the inverter charger. The inverter charger pass some power to the AC panel and other power to activate the charger and keep the battery bank fully charged. This is a wonderful boat. This is the first part. The second part is this. The rest of the boat is the electronic part. The GPS, the transducer, the radar, all the electronic devices, the autopilot system. Those systems are connected in the NEMA backbone. And the NEMA backbone will be integrated here with this cable to the NEMA integration sub backbone. And that one will be connected with the Servo GX. The Servo GX connect with NEMA. In other words, the intelligent boat right now will be integrated with the NEMA backbone. And here, in this one, I can connect the motors, any of those elements, external equipments connected to the sub backbone, and the sub backbone will be integrated with the main backbone, the public network. In the public network, I have all of the equipments. And additionally, if I have analog equipments like the fuel tank, the freshwater tank, the sanitation tank, all of those sensors will be entering here in this panel to convert analog signals into digital signals. For example, here I can connect the black water tank, the freshwater tank, the fuel tank, the rudder, the coolant temperature sensor, oil pressure, through for example, a generator, all generator, the tanks, and all of those signals, analog signals, enter here. Those signals are integrated with the private network, and the private network will be connected with the NEMA backbone. And now the NEMA backbone connected with the Victron system, my friends. And now the boat is completely intelligent. The boat is practically autonomous. Of course, depend on the captain, but the boat make decisions. Okay, this is the project that we are going to do. I am going to divide this project in different episodes, and I am going to explain step by step the process in the propulsion system, the process in the house, the process in the electronics, and the process to integrate all of those elements together in one. I hope you enjoy the future classes and the future book of hybrid and full electric boats. See you later, guys.